Hello everyone. In this lecture, we are going to see the ultrasonic sensor implementation with Arduino UNO. The reason why we use ultrasonic sensor is for calculating the distance of an object which is far away from the sensor, and it can be used in air medium, nothing but normally on where humans or where we or normally walk. There it is used to find distance. For example, if you find some new place, some people will be afraid of going to know whether some snakes can be or some dangerous animals can be. In that cases, we are going to use UGV vehicles, nothing but underground vehicles or some drones. We are going to use to find if any mysterious animal or any dangerous is there or not. For that, this is used to calculate the distance. If something is detected with some distance, then we are going to use some sensors for capturing the photos, and it will send to our mobile phone, nothing but our end device. This is the application of ultrasonic sensor, and we are going to use it with LED as well as buzzer in this experiment. Firstly, we need to study the ultrasonic sensor. By the name itself, you can understand that it completely depends on ultrasonic waves. Waves. By the name waves itself, when waves topic come into the picture, you should understand that we are going to use sound, nothing but echo. I am showing the image. Yes. These are the images of ultrasonic sensor. To observe clearly, this image you can prefer. Yes, it consists of four pins. First is VCC, second one is trig, echo and ground. VCC is always to voltage and ground to ground. This echo is nothing but it is used to calculate the speed of sound through air medium. That is known as echo. This acts as an input and trig will be our output pin. Actually, here it is given in reverse order, but we are going to use trig as output and echo as input. To get echo as we are taking echo as input, you need to fluctuate the trig pin so that we can calculate the echo value. Now, based on that, we calculate duration in our program. Then we are going to calculate distance. And this here you can see it is like two eyes, right? One is for transmitting ultrasonic waves and another is for receiver of ultrasonic waves. That's why one end it will be written as T and other end it is written as R. And this is the crystal oscillator as we are it is used as we are considering the sound waves, nothing but echo. Now let us jump into the program. Yes. In this program, I did not use buzzer, but now we are going to use the buzzer. I will explain first the program step by step. Then we can implement buzzer in this program. As I have mentioned that ultrasonic sensor is having four pins. VCC and ground are always same for all the sensors. Trig pin, select one digital pin value, and for echo also you select one digital pin value. And for LED one value I have taken. Similarly, since I'm also going to work with buzzer, let me take buzzer also. For buzzer, let me consider 12 as my digital pin. We are considering float values because distance we want accurately. Means, for example, we are getting 123.5 something. It will give sometimes 123, sometimes 124. We don't want such mistakes. We want exactly, so we are considering it as float value. Even in real life applications, we use in terms of float value only, not in integer value for calculating these values. Yes, pin mode you can see that trig pin is used for output and echo pin is used as input. My LED is output and also buzzer is also output. Pin mode of buzz comma output. Yes, this is the this step, for starting of serial monitor, serial that began at 9600 baud value. Yes, Now here we need to fluctuate the trig pin in order to get the pulse rate. Based on that pulse, we are going to get the echo pin value. Here in first line you can see, firstly I am making the trig pin to be low and delay in microseconds. Yes, we are using delay function from many programs. This delay function, any value you give inside it is considered as microseconds only. Sorry, milliseconds. Milliseconds is nothing but 10 to the power of minus 3. But here we are going to use microseconds. Micro is nothing but 10 to the power of minus 6. This is the difference. And here you can see delay in microseconds. That is 2 I have passed initially. Then again I made the trig pin to be high and now I am giving a lot of delay time. Actually, by before starting, it should be always low value, right? Firstly, it is low, then I have increased and I have given a delay time. Now again, it's our responsibility to make the pin to be normal state. So again, we are making it to be low. Now, now a pulse is detected. So to work with that pulse value, we need to obtain the duration, nothing but time. Here we are having a function called pulsing of echo pin. Till now we have given fluctuations to trig pin. So echo pin we are going to use now with high value. So duration will be obtained. Now distance formula for making our ultrasonic sensor work is duration into 0.343 by 2. Here the reason why I have taken as 0.0343 is the speed of sound in air is 343 meter per second. So in order to get our actual distance, we need to convert it to centimeters. With including the decimal points, we need to reduce it and then we need to substitute here. And the whole answer is divided by 2. Then we will get the correct distance in terms of centimeter. Here I have not mentioned it. Let me mention it as centimeter. Distance in centimeter. Yes, if distance is greater than 100, we are going to increase the LED value. That is nothing but LED will glow brightly. But in real life applications, for example, if anything is approaching near a valuable thing, then it should ring, not when it is far away. For example, in museum there are some valuable things or in some jewelry shop. When thief comes near to that, then it should make a sound. What's the use when some customer is going far away after seeing it? So there is no use. Let me change this. If distance is less than 100, then you need to make sound. Not, sorry. You need to make the LED glow as well as sound should also be high. Digital write-off, buzz, comma, high. Yes. In a else condition, we are going to change it. Digital write-off, buzz, comma, low. Yes, this is the complete functionality of our ultrasonic sensor. Again, I am explaining, listen carefully. This echo pin works based on the sound waves. And since we are working with waves, there will be a pulse value. So we are going to work with pulsing function. We are going to fluctuate the trig pin and we are going to obtain those pulses. Now we are going to take as, since we consider echo pin as input, from echo pin we are making it high so that we will get the duration and we are multiplying the duration with respect to uh, speed of sound in air. That's the reason I have considered here 0.0343, and this entire answer on dividing by 2 we will get the correct distance value. So if distance is less than 100, we are going to get sound as well as LED on. Otherwise, both will be in off condition. Let me reduce the delay time also. Yeah, this delay function is in milliseconds and this one is microseconds. Let me take for 5 seconds. Yes. Let me compile the program first. Yes, compiling is done. Let me see whether we got any errors or not. Oh, this is serial monitor. Yes, there are no errors. Now I am going to just upload this code and we are going to work with the hardware components now. Yes guys, now you can see my Arduino UNO is connected to my laptop using the USB connector, and this is our ultrasonic sensor. We are having 4 pins if you observe carefully: VCC, trig, echo and ground. VCC and ground I have given here, you can observe 5 volts and grounds. Trig pin as per our program I have given to digital 9 and echo to digital 10. Now we are having LED. I am going to connect now LED positive and negative. Yes, my LED positive and negative are connected. Negative to the ground and positive to digital 13 I have connected. Yes. Now I am going to connect my buzzer. Buzzer positive to digital 12 and negative to ground. Yes, now my all connections are done, and now I am going to upload the code into my Arduino UNO. Yes, I successfully uploaded the code. Now just let me open my serial monitor. Yes, you can see some distance measurements are being calculated, and if distance is less than 100 then only it is going to on. Now you can see my sensor is pointing towards the top. It means this distance is more than 100 centimeters. That's the reason it is unable to calculate. For example, yes, just now I put my finger near to it. That's the reason I got 10 centimeters and 16 centimeters. So the LED and buzzer became on. Now you can see, since I am pointing towards the rooftop, it is showing 300 centimeters and all. So more than 100, those both are off. Yes, now again my finger came into the middle. So it became on. This is how our ultrasonic sensor works. To know whether it is showing original or duplicate value, just let me show this one. You can see it is near to my phone camera and distance is very less between them, right? So you can see here 9 centimeters and all it is coming right now value. Since it is less than 100, now our LED and buzzer will be on again. Just let me keep it. Yes, you can see this is how our application is going to work, and with this our ultrasonic sensor implementation is done. And in the next video lecture we are going to see one of the most important real-time application, that is the smart street light system. Don't miss the next video lectures, as those three we are going to discuss are important. One is the smart street lighting system, one is regarding RFID, one is regarding intrusion detection. So with this, this session is completed. Thank you.